So today we're going to talk about shipping safe AI agents. And thank you to Darko for the previous speech. And I'm going to try and continue from there and hopefully give you some additional signals and points to bring home and to help your experience and your practice with applied AI, thus agents, but even beyond, both for professional workforce, but also on your own leveraging safe AI. We've seen the OpenClaw Mania and others to render your life a bit less burdensome while still having all the advantages of safety, security, and related. So having safety as an add-on that actually adds value, not as more work, more derivable, more compliance. And we're going to, as an thanks you mentioned about the fact that we're going to talk about actual practical examples. So I've worked quite a lot on various agentic systems, and we're going to take learnings from things I've seen and with my team we've seen in production. So I want to start with a sentence. If you think safety is expensive, try an accident. I believe this goes across all industries in a sense, but especially if you think about AI. If you think about it, the risk of a problem can go exponentially as AI becomes better and more kind of attached to our infrastructure and a key in parts of our systems. And as such, we are seeing, and I am seeing through my companies, AI going to ship kind of code in production, sending emails, working with customer records, executing transactions. There are many reasons that this can see problems, and Darko mentioned some. There are others we can see, from simple outage to actual user harm. We've seen examples of all types of liability, actually. There is a place where you can see all the legal cases with AI agents and AI agents being used for legal wrongly, or even cases due to AI. And they are growing very fast. So I want to start with looking at the chat and calibrate my talk based on that. I've also seen the other talks, so I'll try to give some original points there. So if you look here at these 3 points, do you have agents in production? Do you trust them? And do you have secure governance infrastructure in place at the moment with those agents? Can you, if you kind of do 1, 2, 3, and then answer like 1, I'm going to go yes. Then 2, no, myself. And 3, sometimes. If you want to go in the chat and put that in. Or even later on. I'll let you do it. OK? You need the production 1, yes. 2, do you trust them? Sometimes, partially, OK? Thank you very much. So I see a bit of all the options. So let's look at the data, what the data tells us. It is from a gravity study. So it looks like actually a lot of people are using AI agents. 86% of teams are past the planning phase with agentic systems. But you want to know how many of those actually have governance in place or security systems? That drops to a staggering 14%. So we've got 86%, loads of teams doing past the planning phase, so with agents that are actually working actual demos or even production, but a very small percentage of those actually have full security approval to do so, of actually the systems in place for that. And if we go even deeper, 88% of organizations confirm success a security incident with agent this year. 88%. Let's take a moment. Let's think about this in other terms. Oh, yeah, it's all good. Only 88% of our software got hacked. Oh, yeah, it's all right. Only 88% of our employee had a security vulnerability and lost their data this year. Like, this is how high it is with agents currently. And the reverse, you'd think there's so many issues. Well, people are monitoring them, are looking at those issues. Well, actually, no. So that 88% may actually be an undervalue, because most teams don't even monitor 100% of their agent. I mean, let alone 100%, because they probably monitor even less. And there's actually 1 in 100 team that doesn't monitor any agent, doesn't even do monitoring, we can see here that most of them are in the middle layer where some agents are monitored, some not, depends, which is not a problem per se. If you have an internal agent that you only use one as a test, then yeah, it cannot be monitored. But once you have actually agents that are working, even internally, not even in production publicly, but in production internally, well, you need monitoring. It's very important. So we've seen the data, and we've also seen all this pressure to become agentic, AI first, AI powered, AI everything, even a little bit AI washed. And if you feel that pressure, if you feel that discontinuity between everyone saying AI is amazing, then actually thinking, oh, wait, I actually need that agent to work in production, that's why we're here today. So I'm Lorenzo. As Anne introduced, I am director of Excode, which is a nonprofit where we teach coding and AI skills, including agentic skills, to many people. It's one of the biggest courses. We had over 1,000 person in a room. This year was our biggest cohort. And I'm also a researcher in AI safety in Exeter in the UK, and I've done papers looking at how to monitor multi-agent systems, how to work with agentic risk monitoring and assessment, and related things. And I also have my own company where I do enterprise agentic infrastructure. So I take multi-agent systems and agentic systems in companies that usually are in a sandbox kind of planning phase, and I bring them to production and do all the infrastructure around that, so the safety and related. And I'm taking this talk from two main words. So one is the academia word, and the other one is the kind of more professional enterprise word. So the 2,500 deployments are taken from the students that we had in the past 2 years, which we work with them on actually agents and agent safety and ML a bit in general. And the second is enterprise production. So examples from things we've seen. I've worked with the university to do customer chatbot. I've worked with other companies to do things such as agents in various verticals, actually, be it maybe more finance, be it more kind of email management, be it more kind of marketing agents or SEO agents. So across various verticals, it's a bit about taking those learnings and having one clear thing that you can apply now to your agents and to your companies. So the power of agents. I don't even think there's that much. When I started doing conferences, it's actually, I've done over 50 now. But when I started, I remember I had to explain what an agent was like 2-3 years ago. And not everyone actually even had a clear definition, but it's becoming much better. The way I like to define it is taken from academia. So it's kind of a piece of software that is able to take autonomous decisions. So it has agency, it can take decisions, can do things. But this means that then, once you add all the harness engineering around it, you have things such as persistent work, operational leverage, decision support at speed. So it can be very fast, very helpful in plenty of ways, from lead qualification, clinical documentation support, triage, incident support, and much more. And we have kind of now every 6 months, it's becoming twice as effective, or at least in terms of length of work it can do. That's the metrics we've seen now. So agents are very powerful. They can do many things. But at the same time, there's the risk of agents, which is linked with the power of agents. So this means that the same properties that make the agent very powerful, that make them very dangerous. It's a bit like if you in science fiction, or maybe with Spider-Man, it's with great autonomy comes great responsibility in a sense. If you have great power, you have responsibility, and agents have autonomy and power. Thus, you need their responsibility aspects. And these are some examples from Air Canada chatbot that invented a phase policy to replicate agent that deleted production database, although it was then recovered, or browser agents such as Comet or others that expose private user data through prompt injections. And there's other examples of agents causing all sorts of havocs, going from financials and other types. And this is mainly due to infrastructure problems. I mean, the LLMs are the LLMs. You can have smarter LLMs, but it's also an infrastructure problem primarily. It's like saying, I don't know, if I apply to software, you can have kind of better programming language. In the end, it's how you make of it. It's the type of infrastructure you build, is the type of server you use. That will also be a big part of the security. You cannot solve everything by just the model itself, in a sense. So this is an example of how we are right now. So we sit in a car, we buck it up, ready to go, but then we realize there's no steering wheels. There's no brakes, there's no control, it's actually going full speed. Then you multiply that by dozens. And that's what agents are right now in production. So you have no coordination, no guardrails. They're autonomous, fast, yes, amazing. It's like a Ferrari. You feel like you're going 300 miles an hour, but you realize, oh, wait, there's nothing around it. There's no system, there's no infrastructure, but we can build it in. So let's do it together. And this is linked to trust. You were talking about it before. Trust is flowing, and trust is the currency of agents. I'm not going to dwell on that because we had it before. But as trust goes down, usefulness goes down, autonomy goes down. So we need ways to make trust go up. Let's look at it this way. So we're going to look at one root cause. Is one example that I've seen as a problem through my implementation, one architectural fix that I've implemented, and then how to monitor for it long term. So let's say you have an agent right now, and either you realize, oh, wait, it's unsafe, or you have an actual problem, or you lost money, or you lost, I don't know, reputation, and you say, okay, I want to fix it. Let's look at 3 examples about how it's done. Example number 1, an agent that escalated itself. So we've got an agent that has a scope of certain tools. Then it crosses a boundary, and it's able to take another tool and do something else. We've seen this happen several times, especially with coding agents, where they maybe cannot execute some code, so they spin out a terminal, and then they run the code from the terminal, or they do a Python, then write Python, then run it through Python rather than doing something in order to make a change in a file they shouldn't be able to do. So this is about expanding permissions. And usually it's due to the way the tools are linked to the agents. And the way to solve it, we're talking about it before, it's to scope every capability with a structured tool schema. So for me, it's really even just aspect-driven development. It's going with a pencil here and just writing down, these are my 10 tools, 1, 2, 3, 4, 5 on my agent to use. And you don't need hundreds of tools. I mean, Manus, when it blew up, Manus AI, if you remember, it only had something like 40, 50 tools, and it became a $1 billion company. But it had a very good RNS engineering with good orchestration and very good tools, but it's only 40, 50. So you can probably write them down in a couple of pages. And for each tool, do a blast radius calculation. So say, okay, be like a bomb, but say, okay, what can it touch? And then once you've got that drawn out, you can say what should it touch, not what can. And then you have the difference, and you subtract, and you know what you need to remove or what you need to update, in a sense. So if I say, okay, the tool is updating record, say, okay, these are my arguments, okay, it's int, what record it needs to fill, what can it do? It can only write. It cannot do anything else. Maybe it cannot even read, or it can read and write, but it cannot delete. And then you need to define what is linked to it. So if we go a bit deeper on the human in the loop aspect, human in the loop, it's the idea that the human should be involved in decisions, but it shouldn't be a blind human, because otherwise you have decision fatigue. When Anthropic studied human in the loop in their Claude code, they realized that 93% of the time, they just approve without reading. So you cannot have approval by default for everything. It is the same as having no approval, actually, paradoxically. So you need that, you need a very smart way of doing that. And then you can have alert on tools. So you bring alert, you have a monitoring dashboard we're going to present at the end, and say, okay, you have a signal, and say every time you use a tool, you just save it as a trace. Then you say, okay, when it tries to do it, you actually listen to it. In technical AI safety research, you have ways of doing that. I mean, the famous one is when GPT broke out of the sandbox and then messaged the engineer that were working on it while he was kind of eating lunch, and told him, I solved the problem of breaking out of my sandbox, and then finding the solution online and solving the problem, and then messaged the engineer. So here it's not that extreme, because obviously we're not in research, we're in production, but you need that aspect of saying, okay, when the agent tries to go out, I'm not just saying, okay, I blocked it, I'm actually marking it. Because then if I find that every time the prompt is formed in a certain way, it goes and tries to escalate a tool that it shouldn't use, I can go up the stream and either block it earlier, or it may be just a prompt change, like telling the agent beforehand, don't even try that, it's blocked. But you have to be careful around that, because then obviously, depending on the tools it has, if it has a very high access, then if you tell him too much information, it will go around it. Example number 2, hallucinated citations. So you got confident citation, but it goes to nothing. Why? Maybe you've got no chunks from a RAG database. The agent doesn't know what to do, so it'll just generate that. And I've actually seen this, and worked quite hard to make sure that this did not happen, because it's very common with RAG systems. When I was working at the university, we had, because this chatbot, a lot of data, actually, a couple of hundreds of pages of information, and we needed that chatbot to help the students. And students can ask all sorts of questions, and very often the agent, even from those 100 pages, could not find a solution. So initially, they will just hallucinate, and we had to build the infrastructure to teach the agent, I don't know. Foundational models are getting better at it, but the infrastructure actually makes it reliable, as we were saying, deterministic. So this means that the solution here could be ground the answer. One of the metrics I like, and it's also used in AO, AI answer optimization, it's to have a error rate and then kind of factuality rate. So you can measure two texts, the text the agent generated and your text, and then have the semantic difference and have a score and okay, how different it was from what the truth is. Another example would be to cache some answers and don't give everything, just give the cache answers. And one of the things that worked very well for us was teach the agent, when you don't know, contact a human. So this still reduced drastically the amount of queries, because originally all the queries went to a human. Now maybe 10, 20% go to a human, but at least you don't get the agent hallucination. Like the agent goes and tells the human is talking to, look, I don't have this information in my knowledge base, or maybe actually it was also, this information is sensitive, I cannot tell you here. And then he will say, I'll connect you to a human, and the human will come in and chat, and the agent will actually prepare a draft of the entire conversation, put it to the human, so when the human enters, he already has all the information about what is going on. He doesn't have to read the full chat. He knows, okay, this person talked about this, the agent surfaced these three sources, but there is a whole, the date is unknown, or that information is unknown. Can you fill it in? And then the human goes, fill it in, or maybe the human start taking some to chat, and it goes on like this. So kind of having that grounding and measuring it, which then goes actually tracking that citation grounding rate and knowing, okay, we have a lot of information about the events that the company is doing, so the chatbot works very well, but we don't have a lot about the policies. So people don't know what policies there are. So let's either add more information or add another system to kind of fill that in. Or maybe let's say those 10% of answers, Pareto optimization, are asked the most. Let's cache them. So it's not even an LLM, it's a processing engine answering, like an embedding storage. And then there's a good 70%, which is LLM answered. And then there's another 20%, which is human answered. And you need a human, either because of sensitiveness, security, try to have a prompt injection, or because the information is just too hard to find for the LLM. And maybe it's tacit knowledge. And you can have this way a kind of a tracking system that goes 1, 2, 3. Example number 3, multi-agent contradiction. So we've seen kind of one example with one agent using tool, one example with one agent using knowledge, and now what happens when we have multiple agents? Maybe here we have a conflict. So this may happen, for instance, when Perplexity released their multi-agent system, or other organization actually tried. As we're saying, sometimes it adds complexity, but sometimes it also adds a lot of value, because it can cut costs, because you can go to a smaller, more effective agent. Sometimes also increase the accuracy. You can use Fable maybe for planning, and GPT 5.6 for execution. Right now, it's a very good combo. It may change, probably will change in the future, actually. But here we have a contradiction. And the human is like, okay, these two agents have very different responses. Maybe they have different training, or they have different tools, and they come up to different solutions. So what you do is you can add an arbitration state. You say, okay, I have a gate in the middle. And I'll give you an example on how we did this. With Excode, we did a research where we generated a personalized teaching content. So we had learning objectives, and we had kind of difficulty levels, but we wanted to see if, rather than having the same kind of textbook approach to everyone, if we add people to a personality test, and then generated through a multi-agent system, personalized teaching material. And so we built multiple LLMs, of like one that is like a digital twin of the person, one that is like an expert in the content of the material. It was coding an AI material. And then we merged them together. And then we had a reviewer that reviewed things such as sensitiveness or accuracy. And with the test in the eval, we generated kind of 100 insensitive personality profiles of like someone that says, I like World War II Hitler, like something like that, and then say it, and the first agent will go, oh, let me generate an amazing class about Hitler. Then the second agent will go, actually, it's insensitive. Let's come back to that person and ask them to be more serious in their personality profile and in their interest. And this kind of system. And in the end, with that system, we had, for instance, if I remember the exact rate, it was around 85% were good on a first go. So they will just be all right, safety all right, pass all safety checks. We had both deterministic and non-deterministic LLM safety checks, and just going to the user in production, and they had kind of this personalized exercise. A good 5-10% needed retry. So we used a different, maybe smarter LLM or different model to regenerate it with some additional safety prompting that was done by the reviewer. And then a final couple, maybe 5%, needed actually a human to go here after. It failed after 3 generations. So we said, OK, it needs a human to go understand what is going wrong. Sometimes it was like there's a hole in the data, or there's a bug, or many reasons. And then it needed a human to do the arbitration and edit that specific exercise. And in the end, at the end of the process, what you get is you get more engaged students, because obviously they have personalized teaching. So this is an example of going from just simple agents that can be good. They can have very good quality output. But then when you actually went to production for that test, we had 400 students taking it. So you could not just have a human write 400 personalized teaching of like a couple of pages each. I mean, you will need a decent amount of time. We did it in like a day of inference with a GPU. So this is how we took this multi-agent system and brought it to production. And then obviously you can track it as well, kind of inter-agent disagreement, and track failure rate, how many times you need a human to come in, and related metrics. If we go from the solution sides of patterns that prevent this type of problems, I want to present 5 here. So will be scope with tool schemas, which I'm going to skip because it was presented in the previous presentation. Human in the loop, which I believe is probably quite interesting to this cohort. Then eval harness, which also I'm going to go a bit faster because it's talked about later. And then these 2, which are kind of my specialty, especially this one, which is where I wrote a couple of papers on. And I believe this will also be an area of focus of the next kind of 8-9 minutes. So the structure tools, I really like to approach it as a CV. So I was in Croatia doing a workshop about agentic safety a couple of days ago. And I just had everyone sit down and say, OK, let's do your dream hire. So you do a CV, but you are writing the CV of your dream hire. So you have a problem, you want an agent to solve it. Start, just like if you want someone, like who would you want to be there applied? So what will you want them to be able to do? And you can write, OK, I want this task, I want these capabilities, I want this architecture, it should have this security. And then you can treat your agent as employees. Say, OK, the first 2 weeks, we're going to have a human gate. The human will review everything you do. After 2 weeks, if there's an over 80% accuracy, then it will become only just 20% that we need to review. And then you can adjust your risk thresholds based on how it's going. Similarly to how you will do with an employee. Initially, you need to report everything, then you gain autonomy levels. And so the first step for me is really do a CV like agent card. And here you got an example, ML observability agent, and you can see how it is, kind of what it can do, what capabilities it needs, the architecture, the radius, the autonomy, governance, and how it will improve, and how it will go from sandbox to production. We've seen how many projects actually with AI cannot go out of sandbox. So the improvement loop is one of the most important aspects and often is overlooked. So really knowing, even from the start, not the specific, but having a plan for saying, OK, today it's here and it's only with me, but in 6 months or 3 months, it's going to be the entire UK team that uses this, or the entire US team that uses this. And this is where the autonomy gradients works very well, and I really like actually walking through it. So with the agents, when you deploy them step by step, you go, OK, first manual, you go and interview the people that usually do this task, or you find out how this task is usually manually done without the agent. You say, OK, usually human writes and send the email manually. And you say, OK, now let's do it assisted. So we have a small chatbot window next to the email that says, okay, AI start a draft, and then the human reviews and send. Then let's put it supervised. Some emails are sent automatically. It's like, what time is the conference? Hi, the conference is at 7. That's it, easy, done. But some is like, oh, I just had a problem. I lost someone in my family. I can't attend. Can't really have an agent reply like this, or it's a bit harder. So you say, okay, the human actually goes and approves and reviews. Then delegates even more, and then you can go even deeper and say autonomous. The AI executes. You know that you have a crazy, less than 10 minutes answer to all your emails, but then the human only audits after. I obviously wouldn't recommend not even starting, even maybe not even finishing at this stage, depending on the type of task and what happens. But you can really see how you can position yourself and see where are we now, where are we going to be in 2 weeks, where in 6 months, and how to move along that scale. And this is where you can kind of gauge the risk. So you say, let me measure the risk of an action, and then let me see what can get automatically approved and what needs kind of escalation to the human. And this is where we can beat that always human approve system. Because if I only show to the human things that have a high risk score, then I can be very smart about it, and the human will not have to approve 1,000 action, but I still keep the speed of 1,000 action. So I can still have the agent look at plenty of data and answer 1,000 of emails, but only have the human look at 50, which is manageable, maybe, or 100, which is still manageable in a day, if that's your kind of approach. And the eval, as we say, we're going to kind of more stroll over it because other people are going to talk about it after, but it's things such as doing testing on the agent. I believe GPT-Red was just released about a couple of days ago, but there's also Petri from Anthropic and others looking at adversarial test sets and running kind of agentic CI on changes. So having a set of prompts, maybe test of prompt injections, test of data leaks, and then when you deploy a new model, maybe you pass to another GPT, or you change your prompt, you just run your test. Maybe it's like $10, $50 an inference for each run. You can measure that, and based on your risk appetite and size of organization, you obviously tailor it. Some may take hours, some may take minutes, depending on that. And then you can be smart around it and say, okay, let me see which failed, and let me also always update those adversarial scenarios as things update, as new vulnerabilities are found. Pattern number 4, observability. You can vibe code your own observability platform. There are others. With Orbital, we build our own for our customers, where we look at things such as showing clearly how are the agent doing, so what are they doing, how can they do it better, and a bit how they work and where is the risk. And this is where you can, in your dashboard, classify by impact and reversibility. And this is probably one of the best, in my findings, metrics for AI risk. Say, okay, summarizing nodes, it has a low impact. I mean, if you get it wrong, maybe, but it's also very reversible. I can just re-summarize as long as I don't delete the original one. Draft an email, again, it's just a draft, very reversible. I can change the draft. It has higher impact because if someone doesn't read it. Then here, if I go like enrich CRM record, it's harder to reverse because once you have it, you don't think. But if I go here, delete the database, very reversible and very high impact. So I can maybe have a gating system, and I can move those lines based on my risk appetite and say, if the action cannot be reversed in less than an hour, then it needs human reviews. Because then the time that will take to reverse the 10% of the action that go wrong is higher than the time it takes me to review every single action that is not reversible. But at the same time, if something has high impact, it also depends on how you measure impact yourself. And here there are things such as the EUA Act, which is interesting because it also means that you need enforcement and you need compliance. So it's no longer a need if you're in Europe. They delayed it to next year, but it's not only a question of, oh, it's going to be better. Yes, it's a question of it's better because with safety, your accuracy usually goes up and the quality goes up. But it's a question of just non-compliance being very expensive. I mean, if you fail, you can get fines of 35 billion or 7% of global turnover, whichever is lower. So that's how high it is. This is taken from my paper, and I believe we don't have time, so we're going to leave it if you want to chat about it at the end. But what I did is in my research, and we're now implementing it at Orbital, is saying we built a framework where you connect your agent and you get agentic safety. So the framework itself is open source, and the idea is, we did this around a year ago, is there were many agents doing many actions, but there wasn't a way to kind of have that framework saying, is this action safe or not for what I need? So what you do is you plug in your policies, you plug in your kind of agents, you plug in your risk aversion, how risk averse you are, what action you want to do, your kind of your matrix reversibility and impact, and then you get a solution like as a risk score, which is 0 to 100 and says, okay, 0 to 40, it's auto-execute the agent can do, but then maybe this action, the UI Act says it needs to be human reviewed. Thus, we say, okay, human needs to review it because my policy is the UI Act. But then it's maybe an 80 action, so it says the head CTO needs to review it because it's an 80 risk action. And thus, like that, I can move around. And there is the full kind of paper here. Maybe I don't know if I can share these slides afterwards, if possible. So if we go to a close of this conversation, if I want to give you 5 things to do on Monday and to kind of apply to make sure you get it and bring it home. So one is have the agent CV, find, okay, what are my tools, what are my capabilities, build that CV first, like spec, but agent spec-driven development in a sense. 2 is have your human in the loop with get it impact and know where to put it, reversibility or impact. 3 is the evals, so have those CI evaluation sets. 4 is have your audit log of decisions. So this way you can come back and see what actually happened. So what, why, who, which tool. And 5 is have that scoring of a risk, whatever you use, or any other system, really know, okay, this is very high impact, high reversibility. These agents cannot do, it's too dangerous. If you want, I'd be very happy to work with you. So if you want to connect on LinkedIn and message me if you have any agents, I'd be happy to have a look at it and help you if you have any need or questions around that.